Hello there. This is more material from Chapter 6. These are sections 6.4 and 6.5 covered together. And no doubt many of you were wondering in the previous section why we weren't using the quadratic formula to solve the quadratic equation. So the reason is completing the square always works and sometimes is necessary um, in calculus. And it's, to many of us, the more intuitive way to solve problems. But often you have a choice. So if you prefer the quadratic formula, then that is what you should use when you are not asked to do it another way. And of course, by the nature of this class, because you don't have to show your work, you probably will be able to do it whatever way you want. But there may be some problems where you have to do a step-by-step homework problem or exam problem, and you have to complete the square. So make sure you understand how to do this. And then another thing we're going to talk about is how you can decide from the get-go what kind of solutions you're looking for. So no doubt most of you are familiar with the quadratic formula. So if not, let's look at it. This says the solutions to this equation, this is the general or standard form of a quadratic equation where A, B, and C are real numbers. So if there is a real solution, it's going to be given by x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So if you have this memorized, it might be easy to use. If you don't have it memorized, completing the square might be easier. Just like completing the square, though, you can solve any quadratic equation, but you have to remember to first write it in standard form so you can identify the values of A, B, and C. So we're going to solve this in two ways, by completing the square and by using the quadratic formula. So let's complete the square first. Okay, so what do? We isolate these first two terms on one side and put the number on the other side by subtracting 2 from both sides of this equation. Now, what will this number be? Well, b in this case equals 5. This number, remember, is 1/2 b squared, which in this case will be 1/2 b squared will be 5 halves squared, which is 25 over 4. Whoops. Okay, so now we want to simplify this on the right-hand side. So we need a common denominator. So we have minus 2 over 1, and we need a denominator of 4. So I'm multiplying by this number, 4 over 4, which is equivalent to 1. So I see that I have minus 8 over 4 plus 25 over 4, or 25 minus 8 over 4, which is what? 17 over 4. Okay, so let's get some more room. I will just erase this down here now. And we're ready to factor. So how does this factor on the left-hand side? Well, this is going to be x plus b over 2, or 1/2 b. These are the same thing. So that was 5 halves squared, and that equals 17 fourths, right? So now we're ready to use the square root property. So that tells me that x plus 5 halves equals plus or minus the square root of 17 over 4, which is plus or minus the square root of 17 over 2. And then in our last step, we're going to subtract 5 halves from both sides. And we see that x equals negative 5 halves plus or minus the square root of 17 over 2. So we have two solutions here. Let's make room for that. Our two solutions will be x equals negative 5 plus the square root of 17 over 2, or negative 5 minus the square root of 17 over 2. Now, that's completing the square. Now we're going to do it using the quadratic formula. So, what is A? A is the number in front of x squared. So A equals what? B equals 5, C equals 2. So now we're going to substitute those values into here. X equals negative B, that's minus B. So that'll be minus 5 plus or minus the square root of B squared, so that will be 5 squared, minus 4 times A times C, all over 2 times A. So be very careful in this first step. You don't want to mess any of these numbers up, or you'll be messed up for the whole problem. So take a quick double check that you plugged in all the right numbers, and now let's figure out what this is. Well, 5 squared is 25. 4 times 2 is 8. 2 times 1 is 2. This is 5. Plus or minus 25 minus 8 is 17 over 2 minus 5, sorry. And we get the same two answers, don't we? 5 plus the square root of 17 over 2, negative 5 that is, and negative 5 minus the square root of 17 over 2. Now let's double check. Yep, same answers. So which did you think was easier? Some people might say this is easier. This seemed quicker. It often it depends. Which one to use depends on the problem. What made this problem difficult with completing the square is that this was an odd number, and so when we divided it by 2, we got a fraction, and that always adds a little level of complexity to your problem, and it's not quite so quick. And that, in this case, I think this was easier. The quadratic formula was the easiest one in this case, but sometimes it's just up to you. Now, the next thing we're going to talk about is how, if you look at the quadratic formula here, this term under the square root, b squared minus 4ac, this is special. It gets its own name. It's called the discriminant. And this tells us a lot. It tells us the nature of the roots of our quadratic equation. There can be no solution. This would be a complex solution, but no real solution. It can be one solution, or it can be two solutions, and we'll be able to tell. The other thing the discriminant can do is tell you, does it factor? Does the quadratic equation that you're looking at, does it factor? Sometimes I like to check that before I start going down the road of other techniques. Okay, now, if b squared minus 4ac is less than 0, that means you're going to have some negative number under the square root. So this means there are no real solutions. There's only complex solutions, which we're not going to cover. If it equals 0, then it has one real solution, and it factors. If it's greater than 0, it has two real solutions. Now, how do you know if this one factors? If b squared minus 4ac, if this is a perfect square, in other words, if you ended up like with the square root of 49, which equals 7, then it factors. Sometimes that's handy to check. You're not tested on this as far as I know right now. It's not in the homework anyway. It's just useful. And also, if you take Math 144 or calculus one day, this can tell you what the shape of the graph looks like. It can tell you something about the graph. These are just some examples. Here's the equation. We just plug in the numbers and see what this is. In the first case, it was negative, so there's no real solutions. For the second example, it equaled 0. There's one real solution. Maybe we should try to figure out what that is. How would we solve that? We'll look at that in a minute. And this one, it's 49. There are two real solutions, and these two should factor. So let's see if we can figure that out. Much room here, but let me see what I can do. We will factor this one, okay? If it has one real solution, it's a perfect square. So 9x squared, that's going to be 3x. And this better be 2, and it should be negative. Let's see if that's right. If you square that out, what do we get? I would get 9x squared minus 6x minus 6x plus 4 equals 0. Yes. So what is my solution? X equals 2/3. On the other hand, this one is going to factor like so. One of them has to be 2x and one has to be x. 3 is also a prime number, so we know that the 3 either goes here or here? So which way is going to work? And we can try it. We'll use test and guess, which I normally don't like to do. But if I put the 3 here and the 1 here, and I put a plus and a minus, what do I get? I get 2x squared plus 6x minus x minus 3. And there we go. So the two solutions in this case are x equal 1/2 and x equal -3, just by solving these two linear equations. Okay, more on quadratic equations. We're just going to do some examples, mostly from the homework, and which method we use will depend on the problem. And so we're going to practice deciding which method to use. There's no simple answer. It depends on the type of the question and your personal preference. Sometimes there are reasons that one is better than the other, and you will learn as you go along. So this really should be example 2, but we're just going to leave it. The method of your choice. What is the discriminant? B squared minus 4ac in this case. Well, a equals 2, b equals -3, c equals -1. So this will be b squared, -3 squared minus 4 times a times c. That's 9 plus 8 equals 17. This is not a perfect square, so it does not factor. Also, if you try to find two numbers, capital A and capital B, such that A times B equals -1, and A plus B, A times B would equal -2, and A plus B equals 3, -3. There are very few possibilities. What could we do? We could have -1 and -2, and that's tempting, right? You might think it factors, but what's wrong with using those numbers? When you multiply them together, that equals +2. So that doesn't work. So the discriminant told me it doesn't factor. Now, what method do we want to use? Here, A doesn't equal 1. So we have to fix that if we're going to complete the square. And this is not an easy number to divide by 2 already. So I would say quadratic formula in this case, but maybe we'll work it both ways. Let's try the quadratic first. So we have A equals 2, B equals -3, C equals -1. Remember how this goes. All right. Okay. So now let's put in our numbers. Minus B will be +3, plus or minus. Now I'm going to do this very carefully. Minus, -3 squared, B squared, minus 4 times A times C, all divided by 2 times A. Now, this is 3 plus or minus the square root of 9 plus 8 over 4. 3 plus or minus the square root of 17 over 4. So my two solutions are 3 plus the square root of 17 divided by 4, 3 minus the square root of 17 divided by 4. And I think this is probably easier than completing the square. Let's see what would have happened. Let's at least start. Complete the square. So we have 2x squared minus 3x equals 1. That's the starting point. Now, we mustn't have a coefficient of 2 here, so I have to divide everything by 2. So really, I have x squared minus 3 halves x equals 1 half. Okay? Now I need to complete the square. I'm going to add something to both sides so I get a perfect square over here. B is now negative 3 halves. 1 half times B would be 1 half times negative 3 halves, which is negative 3 fourths. Do you agree? So that's what we have to square now, and that will be 9/16. Yikes. So that's what we're adding to both sides. So now we have to combine these fractions. 1 half is the same thing as 8 over 16. So I have on the left-hand side this, and on the right-hand side I have 8/16 plus 9/16, which is 17 over 16. Okay, a little more room. What do we do now? We do this. X plus, remember what it will be, x plus b over 2. B over 2 was negative 3 fourths squared equals 17 over 16. So x minus 3 fourths equals plus or minus the square root of 17 over 16. X minus, well, x equals what? Well, first, let's simplify this. This is this plus or minus the square root of 17 over 4. It's starting to look familiar now. So x equals 3 fourths plus or minus the square root of 17 over 4. And finally, I have x equals 3 plus the square root of 17 over 4, or x equals 3 minus the square root of 17 over 4. Okay, so what was easier? Probably this, the quadratic formula. But if you forget the quadratic formula, you can always complete the square. There's one simple thing, really. Of course, we have to make sure the coefficient in front of x squared is a 1. And then you have to remember that we need 1 half b squared to complete the squared. square, and you have to remember that this is going to be 1x plus b over 2 in parentheses squared. That's how it factors. Sometimes that's a little tricky, like factoring this. You had to think about it a little bit. Okay, so let's pause for now, and then we'll talk about word problems and homework.